Good evening, I'm your host, Grandmaster C, and tonight we're going to be going through a chemical formula naming review for a quiz. The first thing you need to know are oxidation numbers. What's an oxidation number? Well, one atom or a group of atoms together that act as a unit, they can have a charge, an oxidation number. If it's zero, they're neutral. If it's positive or negative, that means they're going to react with something. If it's zero, they're not going to react, and that would be kind of pointless. But if it's a negative or positive, then we have some possibilities of reacting. So let's go ahead and look at some examples of oxidation numbers. So here's hydrogen with a +1 charge. Here's chlorine with a -1 charge. Now we can also have something like a nitrate, an NO3, with a total charge of -1. So when we look at the oxidation numbers, these, ladies and gentlemen, in fact, are oxidation numbers. That's what they are. So it can be a -1, a +1, -2, +2, and so forth. Okay. But we also have to look at the difference with a subscript number and an oxidation number. So in this case here, here's an NO3, okay, with a -1 charge. What's the oxidation number? This right here is our oxidation number. That is the charge on all the 3 oxygens and the nitrogen that are combined as one single piece, one single unit. Okay, but wait, what about this number right here, that 3? That's a subscript number. What is that telling me? That there are 3 oxygens in this group of NO3. Well, wait, doesn't it say how many NOs? No. It's NO3. When the 3 is in the lower part, that's the subscript number. That's when we say there's 3 atoms of oxygen and 1 atom of nitrogen. That's the difference between the subscript number and the oxidation number. Okay? All right, let's move on. So we are going to focus on binary ionic compounds. Okay? Now, what do we mean by binary ionic compounds? Well, binary means two of anything. Okay? We can talk about ionic. Well, ionic has to do with our electrons shared? No. The metal will give up its electron and the nonmetal will take it. That's what we mean by binary ionic compounds. So a metal with a nonmetal. But wait, so what are some examples of metal? Well, we can talk about gold, copper, silver, platinum, iron. Okay, that's quite a few right there. We can also talk about mercury. So all those are examples of metals that people use. Oh, and aluminum, that's another one. So all of these are examples of metals that they will give their electron to a nonmetal who will grab it. Now, what are nonmetal examples? Well, when we look at nonmetal examples, ladies and gentlemen, they do exist in different forms. It could be something like chlorine with a -1 charge, for example. It could also be hydrogen with a -1 example, but that's a metal hydride, because usually we think of hydrogen as a +1. Well, when it's hooked up with a metal, that makes it an exception, and it's a metal hydride. Okay, but we can also talk about other non-metal examples. We can look at Cl, chlorine, 3 oxygens with a -1 charge. This is another non-metal example, and if you notice, you got 4 atoms here in comparison. Okay, so you have metal examples and non-metal examples for your binary ionic compounds. Okay, metal and non-metal. Okay. Let's talk about balancing formulas. How do we do this? Now, the chief goal for having that, ladies and gentlemen, is that the charges, the positive and negative, must equal 0. Because that's the only way that the formula itself is going to be stable. Because if it's positive or negative, it's going to look for something in order to make it 0 and thus stable. That's the whole idea. So, we're going to use the crisscross method. And we're going to look at silver chloride here for an example. And I happen to have my ion chart here. Now notice silver chloride. We didn't say chloride silver. The metal always goes first. Always, always, always. And what were the examples of metals that we had here just previously? Whoops. What examples did we have of metals? Right here. These are examples of metals. So we're going to go with silver on this one. Okay, and I'm going to bring that back up there. And silver chloride. So when I look at my charge for silver, so here it is. Here's silver. There's my Ag plus 1 charge. Okay, I got that. Now I got to go for chloride. Now I know it's got to be a negative charge. So I'm going to go and look here. Chloride. Here's my Cl. And I also have a -1. Okay. So let's go with it. I have silver here with a +1. I have a chlorine with a -1, also known as a chloride. Well, what is exactly the crisscross method? We're going to take the absolute value of this number. So we're going to go change it to a positive number, and we're going to bring that over to here. So that becomes a 1. We're going to take the +1 here, and we're going to bring it over to here. Okay? So, what do we get? We got Ag1, Cl1. Okay? Is it balanced? Yeah, it's totally balanced. The +1 and -1, if you add them together, is a 0. However, we don't write formulas with the ones like this. We don't need to, okay? We can go ahead and say AgCl. And that, ladies and gentlemen, is our totally balanced for silver chloride. Okay? Now what if something isn't a +1 -1? What do we do? You're going to use the same method. Now, we got silver sulfide. Again, I go back, and in this case here, I know where my silver is. Right there, Ag with a +1. And then I've got a sulfide. Sulfide. Ah, here it is. Sulfide with an S and a -2 charge. Okay, we now know what we got to do. We know that there is an Ag with a +1. We know that there is an S, the sulfide, with a -2 charge according to our ion chart. So with that kind of looks like an H, doesn't it? All right, let's fix that. Boom. Now, all we got to do is the power of the crisscross. That's right, a crisscross. So, we're going to change this with the absolute value bars and make this a +2. So we're going to have an Ag2, and over here we're going to have a 1, and we're going to bring that down to the S, but we don't show the 1, do we? No, we don't. So we have Ag2S. That is silver sulfide. Okay? And that's it. You'd say, well, how do I know that it cancels? Well, each Ag is a +1, right? So 2 times +1 is +2. Here you only have 1 of these sulfides. That's a -2. So +2 and plus a -2 gets us 0. It's stable, it's balanced, and off we go. Hey, how about calcium chloride? Okay, well, in the interest of speeding things up, we're going to go ahead and say, here's calcium with a +2 charge, okay, and here's chlorine with a -1 charge. I did cheat, I do know this on the ion chart, but again, we're going to do the same thing with the crisscross, okay? We're going to go, okay, bring that over to the calcium, and then over here we're going to take the 2 and bring that over here to the chlorine. So what in the world is that going to look like at the end? It'll be CaCl, oops, CaCl2. That's going to be our final thing here. Balanced. We got a Ca with a +2 total. Here each Cl is a -1 times 2. That's a 2 times -1 is -2. Plus the +2 we have here, that's 0. We're done. These bad boys are balanced. Okay, whoops. Come on. All right. Now remember, the charges of all the atoms together must equal 0. The whole point about it is stability. Okay? Stability, stability, and okay, I'm doing great. All right. Now let's move on here. When do we use the parentheses? Okay? In balancing the formula. So let's look at potassium benzoate. What do I know about potassium? It's a K with a +1. What do I know about benzoate? I gotta look for it. And, oh, look, it's right here. Benzoate, C7H6O2 with a -2 charge. Okay, so that's a C7H6O2 with a -2 charge. So this is the potassium benzoate. Okay? Now, in this one here, we're still going to do the crisscross method because there's 2 parts. You'd say, but wait, this part has got a lot of atoms to it. So it's still overall a -2 charge. I dropped the marker. Can you believe this? Okay. Oh, the quality of this production just keeps going downhill, right? Okay. So we're going to change that and bring that over to here. And then this one is going to be brought to here. So we'll have K2C7H6O2. So this is potassium benzoate, which is in fact a food preservative. You'll find it in yogurt. Yes. Okay. What about aluminum benzoate? Okay. Well, with aluminum benzoate, guys, it's a little bit different, okay, because aluminum has a +3 charge. We know the benzoate is C7H6O2 and it has a -2 charge. There. This is where you're going to see more of the crisscross thing. Here, you're going to see the crisscross, and where is the parentheses? Because this one didn't have the parentheses. Sorry, guys. Okay. So we're going to still do the crisscross. So we know we have a 2 that's got a beep change to a +2, so we have Al2, right? Now we're going to take that 3 and we're going to have 3 of these. This is where it gets important. C7H6O2. We need 3 of these. The problem is, how do we correctly do it? If I put the 3 here, it's C7H6O23. That doesn't make any sense. If I put the 3 over here, well, you never see a 3 like that. You never see this here. No, 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 no. So that means there's got to be some other idea. In fact, there is. That's where the parentheses comes in, like this. Because this tells me, hey, what's inside here is one piece. I got 2 of these ALs, and I have 3 of these pieces. Even there's a lot of parts, but it's one piece. So Al2 parentheses C7H6O2 with 3. That's it. That's all that it is. Okay? Now, I've got to wind down here on this review. We got to talk about stock formulas, otherwise known as the Roman numerals. Pax Romana! Okay, what do the Roman numerals mean? You need to know this. 1, 2, 3, 4, 5, 6, and 7. Now, in this stock system, are those Roman numerals positive or negative? Do they occur in the metal or the non-metal? They occur on the metal part for this quiz. They're always going to be positive. Why in the world do we have that? Well, the reason that we have that is because we have iron 2 and iron 3 That would be an example. And I'm going to do another thing here with you guys. So let's look at this. Iron 2 nitrate. Okay, so I know I have an Fe, but it's a 2. So that tells me automatically this is a +2. Okay, nitrate, I have an NO3 with a -1, like this. Okay, so I can do the power of the crisscross, right? I need to change this into a 1, and I'm going to bring it down to here. So I'm going to have Fe, and then here I'm going to bring in the 2. I've got 2 of these NO3s. Do I need a parentheses for this? Okay, and the answer is yes, yes you do. Because remember, this is more than one piece. If this was just O by itself, nobody would care. But there's 2 pieces here, 2 separate elements. So yes, you're going to need the parentheses here, and you're going to need 2 of them, and that's it. That's why you need the parentheses. Now, let's check this one here. Iron 3 oxide. Well, okay, oxide is going to be a -2 charge. Okay, and iron is going to be a +3 charge. How come? That Roman numeral. We have the Roman numerals because iron doesn't have one oxidation number. It has multiple. Silver is a +1. You will never see a silver Roman numeral 1. Ever. Because it's the only one. Whereas we have to do this for iron 2 and iron 3. Because while they're related, they're both irons, they are not exactly the same. And they'll behave differently too. They have different personalities. So let's go and finish this up. I got to check on my timing here, and I'm doing fine. Okay, let's wrap it up. We're going to do that. Beep, make this into a positive number, and that's going to be Fe2. Okay, and we're going to bring the 3 down here, and it's going to be O3. Just the power of the crisscross, right? Just the power of the crisscross, and that's what you would have. Okay, we got time for one more. Wait, here's a formula I have. Oh, wait. I'm kind of lost. What am I going to do? Chill. Take a look at that NO3. It's one piece, and you know you got 3 of them. Now you know that the NO3, because you looked it up on your ion chart, is a -1 charge, don't you? The iron, we don't know. We know it's going to be positive, right? We know the iron's going to be positive, but we don't know what kind of a charge. But we can get a clue. Here we go. We've got 3 of these NO3s. So that means this whole thing here, because you've got 3 of these, that means you have a total charge of -3 of the NO3s, because you basically have 3 of them, don't you? Right? So why can't we uncrisscross? Why can't we take the 3, bring that back? There's only 1 iron, right? Well, that tells us, guys, that the charge on the iron has to be a +3. So that iron has to be a +3. So when we write it out, what is that going to look like? It's going to be iron 3, because it's a +3 charge, right? Nitrate. That's it. That's all that there is for this one here. So guys, we've covered quite a bit here. All right, and I tried to show you all the tricks and the tips on how to work out for balancing out and naming binary ionic formulas or compounds. All right, this is Grandmaster C. I'm signing off. Peace.